Hey everyone, this is Esther here. Welcome to my channel. Today we are going to be starting the chapter 14 statistics part 2 introduction. So in the previous session we saw part 1. If you haven't watched that, make sure to check it out. I'll link the YouTube video in the description box below. Okay, so I'll put the link of the intro part 1 of this chapter there. Okay, so now in this session we are going to be seeing about the graphical representation of data and the measures of central tendency. Okay, these are the two main things which we are going to be seeing, and under this we have subtopics and stuff which I will be discussing in detail as well in this session. So let's get started. So first of all, graphical representation of data. When we have data, if we represent it through graphs, through various types of graphs, we call that as the graphical representation of data. Now we can represent data graphically through three types of graphs, that is bar graph, histograms and frequency polygon. We are going to be discussing about these three graphs in this chapter. Okay, first of all we will study what is a bar graph. Now, bar graph is a pictorial representation of data in which usually bars of uniform width are drawn with equal spacing between them. On one axis, say the x-axis depicting the variable, the values of the variable are shown on the other axis, say the y-axis, and the heights of the bar depend on the values of the variable. Might be something which you may know or may not know, but let me explain it to you in detail. So as you could see, in bar graphs we represent the data through bars. Okay, and the space between each bar should be equal, like how this is shown here. So basically this whole let me use a darker shade, this whole box, okay, this whole box, we call this to be 1 unit. This is 1 unit. Like this, every other box also will be 1 unit. Suppose you are leaving 1 unit space from 0 and you are drawing a bar. You must also leave a 1 unit space before you draw the next bar. It mustn't be like you would leave one unit space in the beginning, and then you would draw one bar, then you wouldn't leave a space and you would draw another bar, then you would leave a space and draw another bar. Such things shouldn't happen. But suppose you're leaving 1 unit space between each bar. This type of concept must be maintained throughout all the types of bars you're drawing. Basically there must be a uniformity. Okay, so we have something called as the x-axis and the y-axis in a bar graph. Okay, and the y-axis basically shows all your numbers and all your values and everything, whereas on the x-axis we have the variable. Okay, so the heights of the bars also depend upon the values of the variable. So meaning, according to the given data, suppose 3 students are born in January, your bar would be of this length in this image, right? And if 4 students are born in February, your bar will be like this. So according to the given data, the height of the bar will vary. Okay, but the width of the bar must be fixed. Okay, it mustn't increase or decrease. If the width of the bar is 1 unit of one bar, if it is 1 unit, then the width of the other bars as well must be 1 unit too. Okay, now hope this is clear, and this is how we draw bar graphs. Okay, and always while drawing bar graphs you need to mention the x-axis, y-axis. What is the x-axis depicting? Here it is depicting the number of years, that you must write. On the y-axis, what are the values depicting, that also you must write. Okay, and on top you must always write your scale. Very important, you need to always write the scale. Okay, for example, 1 unit is equal to 20 boxes. Okay, for example, or if you are leaving 2 unit space, or you are considering 2 units, then 2 units must be equal to this many boxes, students, etc. Like that your scale must be written. Now next, moving on to histogram. Now histogram is a form of representation like the bar graph, but it is used for continuous class intervals. Now you know that in a bar graph we do not place the bars together, they are spaced, right? They are spaced. But the histogram is the complete opposite of this, where either you are going to leave a space in the beginning and you're going to draw continuous bars like such, or you are going to be not leaving a space at all. Maybe you might just start from here, it depends. Okay, but suppose you are leaving space at the beginning, we put this heartbeat sort of sign, we say. Okay, and there's a particular name for this, totally forgot what it is called, but we place this heartbeat symbol if you are leaving this space before you start your graphs. Okay, so between 0 and your starting value, whatever space is there, right, that is covered by this heartbeat symbol. You can see it here, right? Yeah. So we use continuous class intervals while using histogram. Okay, so like you will have 30.5 to 35.5, 35.5 to 40.5. It would be continuous like this. Okay, and again the width also must be same, like 1 unit it should be there, and or 2 units depending upon your graph. The height of the bars also will depend upon your data. Okay, now wait is yet another way of representing data graphically. So we represent data through frequency polygons, either with the help of histogram or without the histogram. First we will study how we can represent data in frequency polygons through histograms. So for this we basically need to find the midpoints of the class intervals used in the data. So how do we find out the midpoints? The midpoints or the mid values can be found out using something called as class mark. Now we had studied before that the class mark is the sum of the upper limit plus lower limit divided by 2, right? And also the class size is the difference between the class marks of two successive classes, right? Now basically let us first take the interval 30.5 to 35.5. Now if you have to find the midpoint of this, you know this is the upper limit and this is the lower limit and this is the upper limit. So upper limit will be 35.5 plus lower limit is 30.5 divided by 2. So 35.5, 30.5, let's add it up. So we will get 66, right? So 66 by 2, which will be 33. Okay, now 33 will be the midpoint. So in the graph basically you will have your midpoint as 33. So when you are using your graph sheet, you can easily see where you can find 33. Okay, another example would be this chart which you can see here. Now if you have to find the class mark of this, we can add the upper limit plus lower limit divided by 2. So upper limit, let's say we are going to take 0 to 10 class interval. Okay, 0 to 10, the upper limit would be 10 and the lower limit would be 0 divided by 2, which will be 10 by 2, which will be 5. Right now here I'm not able to mark the 5, but I think it would be somewhere here, right? So this will be your class mark. Let's try for 10 to 20 class interval. So for this, you know, the upper limit will be 20 plus lower limit 10 by 2, which will be 30 by 2, which will be 15. Obviously you can see that this point here will be your class mark. Okay, so how are we going to draw the frequency polygon then? So basically if I find out the class mark of all these bars here, okay, let's say these are all the mid values, when I join all these points, okay, using a scale. Right now I'm just roughly doing it, but using a scale, when you do it, you have your frequency polygon. Simple, right? Simple. So this is how you find out your frequency polygon with the histogram. How about without the histogram? So without the histogram, again we will need the midpoints. Okay, we will call that as the class mark. So again upper limit plus lower limit divided by 2. Okay, let's say these okay, let's take another histogram for example. This table and this frequency polygon. So you will be given the classes or the class intervals and the frequency here. Now you have to construct the frequency polygon without the histogram. For this you need to find out the class mark of each interval. Suppose for 140 to 150, the class mark would be 140 plus 150 divided by 2, which will be 290 by 2, which will be 145, right? So class mark is 145. Now all you need to do is basically write these class marks on the x-axis. Okay, whatever class marks you're going to be finding. So first you're going to start with 145, 155, 165, 175, 185 and 195. And here on the y-axis you will be having your frequencies and stuff, 2, 4, 6, 8, just for sample I'm telling. Okay, now you need to basically mark the points here, okay, according to their frequency. So for 145, frequency on the y-axis will be 2, so your first point will be here. For 155, frequency will be 10, so the point will be here. 165, 20, and it is gonna go higher, right? So you are first of all going to join these points. Okay, let's say your graph goes something like this, and for 195 again frequency will become 2. Okay, 2, but this frequency polygon is open, it's not a polygon yet, right? It's open, it needs to be closed somehow. So how are we going to close it? We are going to place the frequency which is we are going to place the interval which is before this. So 145 to 155 you have, but 135 to 145 we need to make another interval. Okay, and it should be the interval should have the same difference as the other intervals, like 155 minus 145 will be 10, 145 minus 135 will again be 10. So the difference between each of these intervals should be the same, so it should be 10, 10, 10, 10, 10. Similarly 195 to 205, okay, you need to 205, right? Okay, to 205 you need to make. So now you just all you need to do is just bring it down here to the tip, so you will make a closed polygon, right? So this is how you make the frequency polygon without the histogram. Next, moving on to measures of central tendency. Now we have three measures of central tendency: mean, median and mode. Let's see each of this in detail. First is mean. What is mean? It is the average of the number of observations, and it is calculated by dividing the sums of the values of the observation by the total number of observations. So basically they're doing nothing but explaining this formula. Okay, so mean is equal to sum of all the observations by total number of observations. Let's understand this through an example. We have 5 people who are asked about the time in a week they spend in doing social work in their community, and they said 10, 7, 13, 20 and 15 hours respectively. Now we need to find the mean. Now we know that mean is the average basically, and the formula for mean goes like, let's say mean is x, that means it will be equal to sum of the observations by the total number of observations. So sum of the observations means how many observations we have here? 1, 2, 3, 4, 5. We're going to add all these observations, that is 10 plus 7 plus 13 plus 20 plus 15 divided by the total number of observations, which will be 5, right? So add all of this: 10, 7, 13, 20, 15. So 7 plus 3, 10, 15. So 1, 2, 3, 4, 5, 6. So 65 by 5. So that will be 13. So your mean will be 13, that is the average value will be 13. Now we can also calculate mean through another way, that is through grouped data. Now how do we do this? Basically we use this formula of group data, that is x is equal to summation f I xi by summation fi. Now what is summation? This value or this symbol which you can see is the sum basically, and fi is nothing but your frequency, and xi is your whatever values you have here, like 20, 40, 60, 80, 100. Okay, and f will be its frequency. Now how we are going to calculate the mean using this formula? Let us see. Now we have this table which I have written here as an example. So if you are going to use this formula summation fi xi, that means summation, the sum basically. So that will be fi so basically frequency of each value multiplied with its values. That means it will be 40 into 20 plus 60 into 40 plus 60 into 30 plus 80 into 50 plus 100 into 20. We have to add its sum. Okay, all of this sum by summation fi, meaning the sum of the frequency basically. So that will be frequency sum. Here at the bottom they're given 200. So 40 to 20, 800, 60 into 40, 2400, 60 into 30, 1800 plus 4000. I mean, I'm just quickly multiplying. Okay, plus here 1, 2, 3 zeros. Okay, now let's add all of this up. Okay, okay, if you add all of this up divided by 200, I'll write this at the top, okay, in this ink. So this will be equal to, here you'll get 0, 0, 8, 16, 17, 18, 19, 20, 2, 4, 6, 7, 8, 9, 10, 11. So he will get totally 11,000 divided by 200. 2 zeros, 2 zeros, you will have 55. So basically your mean will be 55 of this data. Understood? So the mean x will be the summation fi xi, meaning frequency of each value multiplied by the value, and that we do for all the given values here. So that is the sum of all the frequencies multiplied by their respective values by the summation of the frequency, meaning the sum of all the frequencies, right? So that's how we got 55. I hope this is clear. Moving on to median. Now we say median is the mid value or the middle value of the given observation of the given number of observation, which divides it into exactly two parts, like the midpoint, right? So we basically, how do we find out the median? First of all, whatever data is given, we arrange it in ascending order. Okay, ascending or descending you can arrange it, but mostly we do it in ascending order. Okay, and then we calculate it. If the number of observation is odd, then the median will be n plus 1 by 2. Now what is n? N is nothing but the number of observations, okay, plus 1 by 2. If the total number of observations is odd, or if it is an odd number, we will say that that number of observations plus 1 by 2, that value or that particular observation will be the median. But what if it's even? We will use this other formula. So let's just see how we can do this through examples. Okay, now here the height in centimeter of 9 students of a class are as follows: 1 2 3 4 5 6 7 8 9. Now we have 9 values here. Okay, so number of observations is equal to 9. Now if you have to find the median, now you see that this is a odd number, so that will be, if it is an odd number, we will use the formula. Which formula? N plus 1 by 2 th term. Th term means that particular term. So number of observations is 9 plus 1 by 2. So this will be 10 by 2, which will be the fifth observation or the fifth term. So we understood that the number of observations is 9. Median also we found out, but can we just directly apply it here? Absolutely not. In fact, suppose in the beginning we were supposed to arrange it in the ascending order, right? So ascending order, let's see how to do it. First of all, we can see 145 will come, 144, then 145, then 147, 148, 149 and 150, 152, 155 and 160, right? So this is in the ascending order. Now the fifth term in this order will be what? 1 2 3 4 5. So therefore 149 will be the median of this particular data. Okay, let's see one more example. Now here, this is from your textbook only. Example 13 is where the points scored by Kabaddi team in a series of matches are so and so. We need to find the median. Now here, what are the total number of observations? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So number of observations is 16. So is this the odd or even number? Even number, right? And we just saw that for even numbers we use this formula, right? So what is the formula? Let's just write it down here. So that will be n by 2 th term and n by 2 plus 1 th term. Okay, now so basically we are going to find out the median, okay, through this formula. So basically, first of all, let's arrange it in ascending order. Here we have arranged it already, it's given here in the solution. So now totally there are 16 terms. Use the formula 16 by 2 plus 16 by 2 plus 1. So this will give you what? 8 plus 16 by 2 is what? 8 plus 1 9. So the 8th plus 9th term, when we add that, right, and we divide it by 2, we will get our median basically. Okay, so 8th and 9th term, here you can see that it is 10 and 14, right? 3 6 7 8 9, 10 and 14. So 8th and 9th term, 10 plus 14 by 2, which will be 24 by 2, that is 12. So basically the median of even numbers is the mean of the values of the 8th and 9th term here. Okay, mean is what? The sum of the observations by the total number of observations. Now 8th and 9th term means there are two terms, so mean will be nothing but sum of all observations by total number of observations. Total, we know that 8th and 9th term goes up to 2 terms, right? And the sum of the 8th and 9th term will be 10, which is the 8th term, and 9th term, which is 40. So basically when we have even numbers, we find out the median by getting the mean of the two middle terms. Okay, so this is how we calculate the median for the even numbers. Last but not the least, we have something called as mode. So what is mode? Mode is the value that appears most often in a set of data values, meaning this is the highest frequency. The number which has the highest frequency in the data will become your mode. Now here in this data, which is the highest frequency, we have 15 2 times. Okay, so 15 comes to 2 times. Next 20, let's see, 20 20 20. So 20 is coming to 3 times. 22 is coming 1 time. 25 is coming 1 time. 30 is coming 1 time. Oh, 1 second. 1 2 3, sorry, 20 is coming 4 times, and 12 is coming only 1 time. So now we have got all our values, how many times it's occurring. So what is the mode? Obviously from this you can see that the mode is 12 because it's the highest occurring number. Sometimes what happens is you will get two modes, which would, suppose if I say 15 is occurring 4 times and 20 is also occurring 4 times, that means the mode will be 15 and 20. Sometimes that happens in few cases, but mostly you will have one mode alone. Alright, so this is the whole introduction to statistics chapter. I hope you understood it, right? And I think mostly this is a quite simple chapter. If you're studying this for the first time, you might feel like it's a lot, but trust me, it is really easy. If you just practice it a couple of times and you focus and you study, you're gonna get it. Alright, so let's meet in the next session where we start with the exercises of this chapter. Thank you so much for watching this session. See you all, and make sure to